Hey students, welcome back to Diksha Vedantu English channel. This is Suhas, your chemistry master teacher. Students, how are you all? I hope everybody is safe and doing extremely great. Students, in this today's class, we discuss entire alcohol, phenols and ethers for class 12 basic students, and also this unit is very important for NEET aspirants and as well as JEE aspirants. Students, share this channel to your NEET aspirant students and JEE aspirant students. One second. Students, before starting the class, if my voice is clearly audible and the PPT is clearly visible, let me know in chat section. Let me know first. The voice is clearly audible, the PPT is clearly visible. If it's visible and audible, then let me know with some thumb impression and other things. I hope the voice is clearly audible and the PPT is clearly visible. Students, the students after watching this video, the students watch the video after live stream, then if you have any doubt, don't worry my dear students, your Suhas sir is always there with you. Then comment the doubt in comment section. Okay students, so let's discuss alcohol, phenol and ether. What is the difference? Otherwise, what is the same thing here? What is the same thing present in these three? Oxygen is present, sir. These three all functional groups, right my dear students? What is functional group? That group hydrocarbon, it is replaced by some hetero atom. That entire hetero atom give the entire idea about chemical property and physical property. We know, right students? Students, before entering to the class, we already know your Suhas sir as some rule here. What? Please do not forget to like the video, like, share and subscribe the channel and also video. Let's start with first thing. Students, alcohol is nothing but, what is the general formula for alcohol? If the group or if the functions or if the compound contain ROH format or OH group, OH as a functional group, these compounds are called as an alcohol. We are already familiar this one. What is the difference between alcohol and phenol, students? Students, in both compound or in both functional group, OH is only a primary functional group. If the alcohol connects with an R group, this R group, if it's alkyl, it's nothing but, it is a straight sign or open sign instead of benzene. If in this place of R, if benzene group is there, then this group is called as a phenol. Both are same. But here R is there now. Here may be alkyl or aryl. R may be alkyl or aryl, not a benzene group. Not a benzene group. But whenever the alcoholic group attached to benzene group at any position, students, we know all carbon atom present in benzene group, they are sp2 hybridized carbon. Right, my dear students? sp2 or sp? Then if you know that one, sp2 or sp, let us know in chat section, my dear students. This about the general information about alcohol and phenol. And other one is there, ether. What is ether, my dear students? This one, no sir, we already learned in class 10th, you only teach this. These are esters. In class 11, some basic concepts also you teach it. These are esters. Ether is nothing but CO bond. It's nothing but ROR dash bond. If the compound in the format of like this, if the two carbon atom or if the two group R group connect with oxygen, these compounds are called as ether. Okay students, it's clear? I hope it's clear. Hi Mahalakshmi. Hi, good morning. Students, I hope it's clear. If you have any doubt relevant to general formulae of alcohol, phenol and ether, then let us know in chat section. Okay students, next move on the first subtopic. Which one is first subtopic? Type of alcohols. Alcohols are classified into three types. First one, monohydric, dihydric, trihydric. Very simple students. If in the compound, if one OH group is present, in any compound, one OH group is present, those alcohol are called as monohydric alcohol. Right, my dear students? Similarly, if two OH group is present, then these alcohols are called as a dihydric. It is called as a dihydric alcohol. Similarly, if it's present three, trihydric. Very simple. These about mono, di, tri, poly is nothing but more than 3. If it presents 4 alcoholic group, then these are called polyidic alcohols. Hi Rudraksh, hi. Okay students, I hope it's clear. Any doubts? If you have any doubt, then let us know. Then more the another second type, primary, secondary, tertiary alcohol. Very simple students. We know OH group is always attached to any carbon group, any one of the carbon group in a chain, maybe cyclic chain, maybe long chain, maybe open chain, any chain. Don't concentrate on that chain. Carbon group, sorry, OH group always attached to carbon group. Yes, sir, we know that. If this compound carbon is attached to one R group, it's nothing but one R group. What is the valency of carbon, my dear students? Here we need to fill carbon valency totally 4. One already form a bond with OH molecule, one with R group, and another 2 with hydrogen atom. Right, my dear students? Right, my dear? Yes, students, this carbon, this alcohol, this whenever the OH group attached to primary carbon atom, then these alcohols are called as a primary alcohol. Alcohol in the same case, secondary is nothing but carbon attached to same R group, either to different R group, not an hydrogen molecule. Either it attached to different R group or same R group, 2 R group. Then this carbon is called as a secondary carbon. Whenever the alcohol is connected with secondary carbon, this type of alcohol are called as secondary alcohol. Right, my dear students? Similarly, what is tertiary? 3R group. If the carbon atom attached to the alcohol is form a bond with 3 different R group or 3 same R group, maybe CH3 group, maybe any other group. But this carbon must and should be tertiary. If this carbon is tertiary, then these type of alcohol are called as tertiary alcohol. Okay, students, I hope it's clear. Any doubt is there, my dear students? Students, please do not forget to like the video. Okay, students, this is about primary, secondary, tertiary. For example, look here. In this example, in this compound, alcoholic group, OH group is attached to carbon, which is attached to one R group. Entire this group we call as an R group only. We call it as a R group, but this OH group is attached to this carbon. We only focus on this carbon. Then this is primary, this is secondary, tertiary. Very simple. Depends upon carbon atom. The alcoholic group, the carbon atom connect with alcoholic group is there now. Depends upon that. As my dear students, I hope it's clear. This about alcohol. As hi Rudraksh, hi Mahalakshmi, as students, good morning for everybody. Okay, this about classification of alcohols. Let's move on to the phenol classification. Phenol, same thing, students. Primary phenol, secondary phenol, tertiary. Very simple. If carbon atom attached to only one phenol group, it is called primary alcohol. Same, students, depends upon the carbon atom. Depends upon carbon atom, the carbon may be primary, secondary, tertiary. If the carbon atom is primary, then it is called primary alcohol. If the carbon atom is secondary, then it is called secondary alcohol. If the carbon atom is tertiary, primary, secondary, tertiary, very simple, students. If the carbon atom, we know, right? Let's take an example of methane molecule. One carbon atom, one bond, it is always formed with OH in the time of alcohol. What is the methanol formula? Methanol formula is CH3OH, right, my dear students? The methanol formula is CH3OH. Whenever we replace one hydrogen by one R group, then this alcohol becomes primary, or in the case of phenol also same. Similarly, if we replace by 2 R group, 2 hydrogen, it is replaced by 2 R group, then it is called secondary. If there is no hydrogen, then tertiary. Very simple, my dear students. If 2 hydrogen present, primary. If 1 hydrogen present, secondary. If there is no hydrogen, nothing, sir, it is tertiary. Very simple, students. Alcohol, phenol, ether, very simple unit. But in this unit, we have few important reaction, named reaction. If you know that reaction, if you learn that reaction, or if you buy this one, you can easily get minimum 12 marks for your JEE and NEET from this unit, my dear students. I hope it's clear, my dear students. Next, move on to the classification of ether molecule. Ethers are classified. This alcohol contains OH group as compound containing sp2OH, OH group of a carbon-carbon double bond. That is to vinylic carbon. Students, here we have another type, vinylic carbon or aryl carbon. If the carbon attached to functional group is there now, the carbon, it consists double bond. If it consists double bond, this type of alcohol are called vinyl alcohol. What is vinyl alcohol? The carbon attached to functional group is there, na? The carbon is attached to the functional group. This carbon which is formed double bond with other molecule, or if it consists double bond, otherwise the next atom or the next molecule or the next element after the double bond, if functional group, if it is an alcoholic group, then these type of alcohols are called vinylic alcohol. Yes, students, I hope it's clear. It's clear, my dear students. Any doubts? Next, move to the phenol. Hey, what happened? M in +1. Hey, what is that question, man? Rudraksh, what is that question? Please explain once. I give clarity, don't worry. Next, move on to the phenol, same classification, monohydrate. If the benzene ring is attached to single OH group, this type of phenols are called monohydrate. If it's attached to 2 OH group, dihydric, 3 OH group, trihydric. Students, before entering to the benzene molecule, students, I give one simple clarification related to benzene molecule. Students, what is the molecular formula of benzene molecule? C6H6, sir. This is a structure. Students, every atom, every carbon atom is same. And in entire benzene group have high density of electron. In entire benzene group, high density of electron is there. Whenever the OH group and other group is attached, na, it behaves. Sometimes the group behaves as an electron withdrawing, electron donating. I already explained in class 11. Right, my dear students? In the some basic concepts of chemistry, I already explained that. Sir, can you make a video on important question from chemical reaction and equation? Okay, I do that, ma. Hema, I do that. Definitely. Okay, today only I do that. I think I already uploaded that video. No. Oh, no. I do one thing, Hema. Top 15 important question or top 30 PYQs on chemical reaction and equation. I take live session on next week. I take live session in next week. Please attend that session. Okay, Hema. Okay, are you happy now? Hema, happy? Yeah? Okay. Hey, students, whenever the group is present here, then these next to the position, the carbon present next to the group is there, na? This place is called ortho position. This position is called ortho. Exactly opposite position is called para, and this next to the ortho group is called meta. First ortho, meta, para. This is very important, my dear students. This is very important. I told once again, students, if the R group attached in this position, then the next carbon atom or the next position is there, na, in benzene group. That position is called as what we call. This position is called as ortho position. After the ortho, meta position is coming. Exactly opposite or exactly the opposite carbon is present, na, to the group. That group, it is called as a para. Sir, class 11 के कब class होगा? What, Divya? Please tell in English, okay? I don't know Hindi. Okay, sorry for the students. Next, move on to the classification of ether. Ethers are classified into two types: symmetrical ether and unsymmetrical ether. Very simple. We already know the format of ether, right, students? The general formula ROR. This is a general formula of ether. If this both R group is same, then these type of ethers are called symmetrical, one thing. And if the both R group is different, then these type of ethers are called unsymmetrical ethers. This about entire classification of alcohol, phenols, and ether. Very simple. Alcohols, we divided into three types: monohydrate, dihydrate, polyhydrate, that thing, and also primary alcohol, secondary alcohol, tertiary alcohol. And after that in phenols, monohydrate, dihydrate, trihydrate. Very simple. And after that in ether, only two types: either symmetrical, either unsymmetrical. Very simple. If both R group is same, then these ethers are called as a symmetrical ethers. When both R group is different, R is not equal to R, both are different, then these type of ethers are called unsymmetrical ether. Okay, my dear students, I hope it's clear. Related to the classification. Here we have NTSE questions. These questions are very important. If you solve this question, then you can easily score out of 4 marks in your class 12 board exam and also NEET and JEE students. Here the first question is, what is the first question? Classify the following as primary, secondary, tertiary. Here the alcohol group is attached to this carbon atom. This carbon atom has 2 hydrogen. and it is connected to only one R group. One hydrogen is replaced by entire R group. This entire compound, this entire part we call as a R, because we only concentrate on this carbon atom. That's why this one is primary alcohol. Okay, primary thing. In this compound also same primary. In this example it is also primary. In this one students, only one hydrogen is present. That's why it is a secondary. It's nothing but here one R group, and this called as, or this take as another R group. That's why it is secondary alcohol. Okay, students. Then in this compound, in 7 compound, here look here, this carbon atom have one hydrogen and it is attached to 2 different R group. That's why this is also secondary. This one it's 3 R group. That's why it is tertiary. Very simple. I hope it's clear. Any doubt is there regarding about this subject? Sorry, regarding about these questions, this index questions. Very simple, students. If the carbon atom, we only focus on the carbon atom which is attached to OH group. If this carbon atom have 2 hydrogen, then it is called primary. I give trick here. And if it attaches to 1 hydrogen, then it is secondary. There is no hydrogen. It's entirely attached to 3 different R group or 3 same R group. Then this carbon or this alcohol called as tertiary alcohol. Okay, my dear students. I hope it's clear. Then let's move for the next one. Next thing. The next thing is common and IUPAC name of alcohols. Right, students? We already know, right? Clear, sir. Thank you so much, Rudraksh. We already know. What is IUPAC? What is the full form of IUPAC? The IUPAC full form is, what is the full form of IUPAC? International Union of Pure Applied Chemistry. Full form of IUPAC, students. Students, we already know. I give simply summarize the topic, or I give simple few tricks how to find the IUPAC name for any compound. Students, IUPAC, entire IUPAC name is divided into 3 parts. First part, it is for, we divided into substituent. Then second part, parent carbon atom. Then primary or functional group. It is also called as prefix term. Then parent atom, same parent carbon atom, then suffix term. This is the 3 form. If you know this concept, then you can easily make a name. International Union of Pure Applied Chemistry. Super, Emma. Correct. You can easily name any compound by using this property. Very simple, student. First, count the carbon atom present in parent chain. Then write its root word. After that, then find the functional group, primary functional group. Okay. After that, simply write the suffix relevant to the functional group. For alcohol, what is the suffix? OL term. We need to replace E term by OL term. Very simple. Substituent we already know. Numbering is always takes place. On which basis? The substituent have lower priority. If we give number to any compound, then the substituent is present now. It get minimum low priority. We already know, right, my dear students? This about IUPAC. Here we have few compound. We have few alcohol compound and relevant common name, IUPAC name. Oh, it is ether name. Sorry for the students. Oh my God. Wait here. Here there is alcohol. Look here. For CH3OH, the common name is methyl alcohol. The IUPAC name is methanol. Only one carbon atom is present. Similarly, propanol, propan-2-ol. This is called, these are the isomers, right, my dear students? Same functional group. Sorry, say not the same functional group. Same molecular formula, different structure. For branched chain, we always use iso word. We always use iso word in common name. Okay, students? N-butyl sec. Sec is also at second position, second alcohol. It is called second butyl alcohol. Second position, butyl group is there. For example, this one tertiary, second is nothing but not second. Secondary alcohol is nothing but secondary butyl alcohol. This one is isobutyl. Then this one is tertiary butyl. Then same thing. Same thing, my dear students. Same thing. 1 second. Hello, check students, the voice is audible now. Yes, students, it's correct only. Rudraksh, Hema, yes, it's correct. These are the few IUPAC name and common name for few alcohol compounds. It's clear. I hope it's clear, my dear students. Where is the remote? Yes, here. Then after this, ether, alcohol, phenol compound is very simple, students. If we have phenol compound, this entire compound named as phenol, it's present either the substituent present in different position. Always the numbering is taken place from this side only. Always we give priority for functional group, right, students? First we give priority for functional group. Correct, my dear students? Super. Then after this, here we have important in-text questions here. Students, don't worry. For class 10, Emma, for class 10 also we do same thing. Okay. What we do? We take entire NCERT solution. We discuss entire NCERT solution for mathematics and chemistry both. I am only the maths teacher also. I am only the chemistry teacher also for you guys. Okay. Entire chemistry I discuss. Entire mathematics I discuss. Don't worry. I am there, students. I am always there with you guys. Okay, come on. Let's start with here. I changed the color of pen because it's white, right? That's why I changed to red. Here, the first question is give IUPAC name. Here we need to name the compound by IUPAC system. Okay. Always they ask IUPAC on the students. Not they ask for waiting, sir. Yes, super. Don't worry, Emma. I am there. I am always there for you guys. Don't worry. I am like your brother. Okay. Students, come on here. Look here. The first question is give IUPAC name. Here, the functional group is present here. That's why the numbering is taken place from this 1, 2, 3, 4. Totally 5 carbon atom is present, right, my dear students? The name chloro is first, right? Methane is there. Before M, C is coming. That's why the name becomes 4-chloro, right, my dear students? 4-chloro di 2,3 dimethyl 2,3 dimethyl. Totally 5 carbon atom is there. Pentanol, pentanol, 1 all. You need to mention that 1 also. Okay, students, 1 all. Then after this second one, here OH group is there. The numbering is taken place from this side, either this side. Both are same only. It is nothing but the compound name becomes 1,5 methyl dimethyl phenol. Very simple. This compound, this is ether compound. This is nitrobenzene. Very simple. Nitrobenzoxyethane. Nitrobenzoxyethane. In this case, total phenyl compound, propane compound is there. Propanoxy. What is this name? CH2 is nothing but ethane. Propanoxyethane. This is a name. Very simple. And also here we have other compounds also there, my dear students. Look here. Here, alcohol present on this carbon atom. That's why either we take numbering from 1, 2, 3, 4, 5, 6. No, the numbering is taken place from this side 1, 2, 3, 4, 5. Not 5. That's 1 second, students. Wait. Only one alcohol group is present. Then that's why we can numbering from this side 1, 2, 3. Yes. 1, 2, 3, 5. No, here also one functional group is there. That's why the numbering is different here, students. The numbering is different. 1 second, I do that. Whenever these type of questions they ask in NEET level and JEE level, students. Here, the 1 carbon, 2nd carbon, 3, totally 4 carbon atom present. We consider this as an one functional group and this as an another functional group. Here, the naming is taken place from this side. First, 4-chloro is coming. 4-chloro, then a third, 3-ethane, 3-ethyl, and 1, 2, 3, 2-propyl, totally 4 carbon atom is nothing but butanol. This is a name of this compound. Okay, my dear students. And for this compound, this is homework for you guys. Please do that in homework. Okay, for this very simple. Here the 1 is there, 2, 3. We need to consider this ethene. Okay. This entire become R group. Same thing here also. 1, 2, 3, 4. Same, if 2 is there, then its name becomes at second position bromo is there, 2 bromo, 3 methyl, 2 bromo, 3 methyl, and at second position double bond is there, ethane, 2ene, H2ene, and 1 all, H2ene, 1 all. The name become like this, students. Don't confuse, okay? Don't confuse. I explained already, okay? I hope it's clear. If you want, I explain once again. Don't worry, students. I do one thing. I make a video on entire IUPAC system, okay? Entire IUPAC system, I make a one video and relevant questions. One day I come with live of entire IUPAC system. Then if you have any doubt, then you can ask on the system, okay? Sorry, on that live session. Okay, my dear students. Next, move on to the structure of functional group here. In alcohol is there now, the oxygen OH group is attached to a carbon by a sigma bond. How OH group is attached? By sigma bond. We already know, sir. We know in water molecule, what is the bond angle, students? It's across 108.9 degree, and also this bond length is 142 per meter. Sorry, PM 142 PM and 96 PM. And also here also same thing in phenol. In everywhere the bond angle is different. Look here. Here in the phenol case, the OH bond angle is there. It is 109, and the O bond length is there now. O and the carbon bond length in phenol group, it is different. It is 136 PM. Here also, what is the bond angle? It's 141 PM. These two are approximately equal. Okay, students, here what is the entire case? Hi, Neta. I'm Madhvi. Yes, I remember you. How can I forget you guys? I'm always remember you guys. Don't worry. Okay. In this case, here few words is there. The bond angle in alcohol is slightly less than tetrahedral angle S. It is slightly less in tetraangle, and it is due to the repulsion between the unshared electron pairs of oxygen. Why? Because due to repulsion. The phenols, the OH group is attached to sp2 hybridized carbon. I already told all benzene atom as sp2 hybridized carbon atom. Then carbon and aromatic ring. The carbon oxygen bond length is 136 PM. In phenol is slightly less than in methanol. Compared to methanol, it is slightly less. The bond length is there now. CO bond length, it is less. Right, my dear student? And also partial double bond character. This thing is happened very simple. Here they give some idea about structures. Okay, now we are coming to main part of the lesson, preparation. Preparation of alcohol is very, very important, my dear students. First, from alkenes. First preparation is from alkene. The preparation of alcohol from alkene. The first step is what happens, students? We already know by acid catalyzed hydration. First step is acid catalyzed hydration. What happened? Alkenes reacts with water in the presence of acid as a catalyst. Students, first here we convert entire water molecule to H3O plus ion. Look here, H3O. What acid do? Acid ionizes or dissociated to form H plus ion, and it reacts with one water molecule and it forms H3O plus ion. Whenever we dissolve the acid in water, what happened? I didn't see any teacher teaching in the front. Thank you so much, Malvi. Thank you so much. Thank you so much for your beautiful comment. This type of comment always remember. I always remember, students, in my heart. In my heart, I always remember this thing. Okay. Okay, students. First, this is a first preparation. This is a first preparation. The preparation of alcohol from alkene. First step, what happened? In first step, water molecule is form a bond with H plus molecule and it forms hydronium ion. In hydronium ion, O plus molecule is there now. This double bond. This double bond, we always know this double bond attached to this hydrogen, and what happened? This double bond is broken. This double bond is broken, and here one hydrogen molecule is attached. Then this carbon atom becomes positive. Okay. In second step, same water molecule, nucleophilic attack of water on carbocation. Here carbocation is forming, students. Then second step, water molecule is attached or it is attacked. Then it forms alcohol molecule. But here positive charge is there. Why, sir? Because one bond or one pair of or one lone pair, it is participate in bonding. One lone pair of electron of oxygen, it is participate in bonding, students. And then in last step, what happened? Deprotonation. Deprotonation is nothing but one pair is there now. Similarly, H3O plus molecule is forming. This oxygen, the lone pair present in oxygen, which which attack the hydrogen molecule which is present in the carbocation, and this bond is moved towards, or this bond, entire bond moved for the oxygen molecule, then the positive charge neutralized. I teach once again, students, I teach in next sheet. Wait, I change the color of pen. Okay, what happened? We know, right? This is an alkene molecule. In first step, water molecule, we already know. Hydroxyl ion, it is always small ion. It is further react with water molecule and form hydronium ion, H3O plus. We know, but what is the exact structure? This one. This is an H3O plus molecule. This H3O plus is there now. This double bond is react or is attack. This double bond attack this hydrogen, and here carbocation is forming. First step, carbocation is forming. Hydrogen is attached to this carbon, and what happened here? Carbon valence is not satisfied, right? Here in this carbon valence is not satisfied. What happened here? Only 3 bonds is there. For carbon, we know we want 4 bonds, or the valency of carbon is 4. That's why this carbon forms a cation, carbocation. What happened? Carbocation is forming. This is entire first step. In second step, what happened? The nucleophilic attack is happened. Water also one nucleophile. Water molecule is also a nucleophile. Why? Because we know nucleophile is nothing but it has higher electron density or higher lone pair of electron. In oxygen, we have two pair of lone pair of electron is there. In water molecule, one electron forms a covalent bond with one hydrogen and another one hydrogen, and then we have two pair of electron, two lone pair of electron is there. One lone pair, what happened? This one lone pair, it attacked this carbocation. The carbocation, we already know, nucleophile always search the carbocation compound, which found that this carbocation, and it is attacked that. Why? Because in reaction medium, we have water molecule, more water molecule. It attacks it. Then after that, what it forms? It forms like this. I write here. Here one hydrogen is there, and another 2 hydrogen molecule or another R molecule is there. Then after that, OHH bond is formed. But oxygen carries positive charge. Why is that? Because the entire one lone pair is participate in bonding. That's why here there is no stability happened. We want stable compound. Whenever the compound is forming, that compound must and should be stable. We already know that compound must and should be stable. For that, deprotonation is happened. Deprotonation is nothing but further another water molecule is there now. We take another different water molecule. This same water molecule attack this hydrogen, and deprotonation is happened. This hydrogen is removed. This proton is removed, and this bond is there now. This bond entirely taken from this oxygen. That oxygen, okay. You go right, you just leave. Give that entire lone pair to me. If you give that lone pair, then I become stable. Please give that. That's why the deprotonation is happened. Then this entire bond move towards oxygen. Then we finally obtain alcohol by using ethene. Okay, first step attack. First step, what happened? Carbocation formation. Second step, attack of water nucleophile. Third step, deprotonation or deprotonation. Deprotonation is happened. Okay, my dear students. Propanol. Next, move on to the second one by using hydroboration oxidation. Very important, my dear students. Hydroboration oxidation. It is very important for your board exam and also for your entire JEE and NEET exam. Okay, they ask this question. In this, what happened? Diborane. Here we use diborane molecule. It's nothing but BH2, BH3, BH3 2 molecule. Diborane. Borane molecule is nothing but BH3 molecule. Diborane is nothing but 2 molecule. Alkane. Sorry, here also we use alkene. What happened? We already know, sir. Whenever the HBr molecule is there, the double bond is broken, and one side hydrogen form a bond. One side hydrogen is attacked, and another side Br molecule. First, HBr is there now. This HBr broken. Hydrogen carries 1 lone pair and bromine carries 1 lone pair. These 2 lone pair form a new covalent bond, right, my dear students? Here this case is happened, and another molecule of alkene react with same molecule. react with same molecule and form this students. Here another BH2 is there now. This is form another BH and form this molecule, and after the same another molecule, then another hydrogen is removed. In the place of hydrogen, this molecule is forming. Then H3O plus is nothing but deprotonation. Deprotonation, then you got a alcohol formant. First step, one HBr molecule, sorry, not an HBr here, HBH molecule is attached. Then on that case, HBH2 forming, and another alkene molecule is reacted, another propene molecule is reacted, then it becomes dipropene, then another propene molecule, tripropene. Here there is no hydrogen. There is no hydrogen is therefore replacement. After that we do H3O plus or deprotonation or anything, or protonation, not an deprotonation, sorry for the protonation. Whenever you do protonation, what happens? This B molecule is replaced by OH molecule, then 3CH, 3CH, 3CH2 molecule is there now. It's behave like this. CH3 tri molecule is only there, then only attached one thing, and BOH3 is forming. This is called hydroboration oxidation. Hydroboration oxidation is nothing but we add, right? We in oxidation place, either addition of oxygen is takes place, either removal of lone pair is takes place, right, my dear students? Same thing is happened. This reaction is called hydroboration oxidation. Why it's called hydroboration oxidation? Because here diboron molecule is there, that's why diboration oxidation we call that. Next, move on to the next synthesis from using carbonyl compounds. Very simple, students. Take any carbonyl compounds. Carbonyl compounds is nothing but the compound consists or contains CO group, C double bond O group. If you do reduction of aldehydes and ketones, and then you obtain alcohol. We are familiar this reaction. Very simple. By using palladium catalyst or by using reducing agent, do reduction. By using any reducing agent or palladium or catalyst, catalytic hydrogenation, if you react or if you add hydrogen molecule by using any palladium catalyst or NaBH4, then it forms alcohol. But students, whenever you take aldehyde, it's give primary alcohol. Whenever you take ketone, or sorry, not in ketone, whenever you take ketone, then this ketone molecule gives secondary alcohol. Okay, and also RCOH is nothing but which one? RCOH is nothing but what, students? RCOH is nothing but carboxylic acid. Same reduction of carboxylic acid and ester. If you reduce this compound, then you obtain this one. If you before reduction, the ester COO bond, first you need to react this ester with alcohol molecule, then it forms ester, another this H molecule, it is replaced by R dash. Then do hydrogen catalyst, then you obtain the molecule. Then you get alcohol and also 2 alcohol. Okay, here both are alcohol only. Primary alcohol, secondary alcohol. Both are primary only. Okay, students, I hope it's clear. By using reduction of carbonyl compounds, either by using, you can use palladium catalyst or any which one, or any what is the any reducing agents. Very simple. Okay, then move on to the from Grignard reagent. Very simple. Alcohols are produced by the reaction of Grignard reagent with aldehydes and ketones. Whenever we react ketone or aldehyde group or carbonyl compounds of only ketone on aldehyde, only ketone on aldehyde with Grignard reagent, what happened? We know, right? This is metal, magnesium is metal, which is attached to extern, is nothing but halide. This R is an it has an del minus value, this one del plus, right, my dear students? It is electron withdrawing group, which withdraw the electron from Mg molecule. This R is attached to this carbon atom, then the O bond, the double bond is moved towards O molecule, the double bond move towards O molecule, then it forms this type of adduct compound. Adduct is nothing but, what is the meaning of adduct? If you know it, then let us know in comment section and chat section, my dear students. What is adduct? Let us know. And after that, protonation or reacting with water. Water is nothing but hydrolysis. After that hydrolysis, you get the alcohol molecule and MgOH. It is also an metal alcohol, MgOH molecule, metal hydroxide. You obtain metal hydroxide. Okay. First step, aldehyde or ketone which is reacted with Grignard reagent. After that adduct is forming. After hydrolysis, then we obtain alcohol. These are the example. These are example students. HCOH, same thing is happening. Okay, my dear students. I hope it's clear. Then next move on to the preparation of phenols. Now alcohol is done. Alcohol in your syllabus totally you have 3 preparations students, from using alkenes, from using carbonyl compounds, from using Grignard reagent. Okay, these 3 are very important, and also diboration oxidation is there now. It is also very important. Next move on to the preparation of phenol. Very simple students, from using chlorobenzene. Whenever chlorobenzene is fused with NaOH, it is NaOH is nothing but sorry for that, alkali, right students? Whenever we fuse chlorobenzene with alkali at 663 Kelvin and 300 atmospheric pressure, students, this condition is very important. If you write wrong condition, then you lose entire marks. Then you lose entire marks, my dear students. They deduct entire marks. Very important. Please remember this also. Okay, what happened? Then it forms sodium phenoxide ion, O minus Na. This Cl group, it is replaced by ONA, O minus Na plus compound, and HCl compound is released. And further, the same HCl compound is reacted with same HCl compound. Then what happened? It formed NaCl, and phenol compound. First step, sodium phenoxide ion is forming, and further react with HCl acid, then it forms phenol. Second one, from benzene sulfonic acid. Benzene sulfonic acid. How to form benzene sulfonic acid, or what is benzene sulfonic acid? This is a structure of benzene sulfonic acid. Okay, students, what happened? First, benzene is sulfonated with olum. Benzene is sulfonated with olum to form benzene sulfonic acid. After that, it is further reacted, it is fused with NaOH, and further protonation, the phenol compound is formed. And from diazonium salt is nothing but NH2. How to form diazonium salt? Whenever the aniline group is reacted with NaNO2 and HCl molecule, whenever the aniline group is reacted with NaNO2 molecule, sodium nitrate molecule, the benzene chloride, diazonium benzene chloride is formed. Diazonium is nothing but N2 group. If the compound containing N2 plus compound, then these compounds are called diazonium salts. Okay, salts is nothing but N2 plus Cl minus. Then further hydrolysis to form phenol compound, and nitrogen gas is released and HCl molecule is obtained. I repeat on students, from aloe arrays, how phenols are prepared? Very simple. First, we fuse NaOH. We fuse chlorobenzene or alobenzenes with NaOH at 663 Kelvin. Sorry, not at 663. I am only wrong, students. At 623 Kelvin, under 300 atmospheric bar pressure, it yields sodium phenoxide ion. After that, further reacting with HCl molecule, then with yield phenol compound. Then after that, by using benzene sulfonic acid, how benzene sulfonic acid is forming? By using the reaction of benzene with olum, then sulfonic acid is forming benzene sulfonic acid, further which is fused with NaOH, and further protonation which give phenol compound. In last one, diazonium chloride salt. How it happens, students? How we prepare diazonium chloride salt? Very simple. Whenever the aniline is reacted with sodium nitrate in the presence of HCl molecule, then it forms benzene diazonium chloride salt or benzene diazonium salt. After that, it further reacted, or it further undergo hydrolysis is nothing but it further reacted, or it is further reaction with water molecule. Here we need to warm the compound. Why? Because it is a condition. That's why, sir. Very simple. It is a condition. Here we need to warm something. Here we need to warm the compound. Then it obtains phenol compound. Then we get phenol compound. Then we obtain phenol. Very simple. These are the preparation of phenol compound. Then after this, here another very important preparation is there. This question is repeatedly asked in your class 12 board exam, and also in your JEE and NEET level questions, competitive exam, for your competitive exams. What is cumin? Cumin is very simple, students. Cumin is nothing but isopropyl alcohol. Whenever, no, isopropyl benzene, not an alcohol, students. Isopropyl benzene, the cumin. Another name of cumin is isopropyl benzene. First step, oxidation. First step, we need to oxidize the cumin, right? As cumin is also called isopropyl benzene. It is correct, sir. It's oxidized in the presence of air. How cumin is forming, students? Not in cumin. Cumin is nothing but isopropyl benzene, sir. We oxidize this compound in the presence of air. What happened in air? Oxygen is there. What happened? It's formed peroxide. Peroxide is nothing but COO bond. COOH. If we have only single H, then it is called single oxide COO. Double oxide is there, then it is called peroxide. Okay. Peroxide is forming. Cumin hydroperoxide is forming. Further it undergo protonation, then we obtain phenol compound with acetone. Phenol with acetone. Very simple. Cumin, it is nothing but isopropyl benzene which undergo oxidation in the presence of atmospheric air. What happened? It forms peroxide, hydrogen peroxide, hydroperoxide, not an hydrogen peroxide, hydroperoxide. Further, it undergo protonation in the presence of water. Then it produces phenol compound. Very simple. I hope it's clear, my dear students. This about the preparation part. Then move on to the physical property of alcohols and other things. Students, physical property is nothing but boiling point or melting point. Right, my dear students? Either boiling point, sir, or either melting point. Students, alcohol, the entire boiling point and melting point, it completely depends upon hydrogen bonding. We know, right? In alcohol, if you consider 10 ml of, if you take an example of 10 ml ethanol, we have so many, we have more than 100 or 500 number of alcohol compound is there. It's completely depend upon two hydrogen bonding, students, either inter or intra, depends upon the molecule. Students, what is the meaning of inter, intra? I explained deeply here. Concentrate here. Concentrate. This concept is very important, my dear students. What is the meaning of inter and intra? Inter is nothing but with other molecule, with same molecule or with other molecule. Intra, within the molecule. If the molecule forms an intramolecular bonding or intramolecular hydrogen bonding is happened, then that compound or those compounds have high boiling point, because another OH bond is forming. Look here, this is an example. This is an example for inter. Inter is nothing but with another OH molecule. Okay, this is a intra. Where is intra is there? Here intra is not there. Where is intra? Intra. No, this not this one. Okay, just leave it, student. Just leave it. Inter, intra. If it forms intermolecular bonding compared to intra bonding, it has low melting point. Sorry, low boiling point. Almost. Sorry. Shit, what's this happening? Yes, always ethanol or obtained in liquid form. Their liquid form, because OH group hydroxyl ion is there. That's why. Very simple, sir. Okay, students. I hope it's clear. Anything is there? Anything else? Anything else regarding about physical property intra and inter? If you have any doubt, then let us know in chat section. And the students, watch the session after the live session. Don't worry, I definitely give a reply for every comment. I clarify for every doubts. Don't worry, please let me know in chat section. If you have doubt, let me know in comment section. Okay, my dear students. Then after that, chemical property is there, and after that, acidity of alcohols and phenols, and after that, which one is there? Acidity. Yes, acidity. Then we have few PKA value. Acidity value depends upon PKA esterification, then reaction with this side, and trimer. Oh, here coming no. Look here, students. Kolbe reaction is very important. Trimer, and some important alcohols. And after that, its preparation, Williamson synthesis, physical property of important methanol and ethanol. Right, students? Electrophilic substitution, nucleophilic substitution, Friedel-Crafts reaction. And after that, oh, this much only. It is very easy, students. Phenol, ether, ester. Is there now? Ester, no, sir. Alcohol, phenol, ether. These three are very important, very easy topics, students. And also, don't worry, I am only taking aldehyde, ketone, and esters topic also. I will only do that entire unit. Okay, my dear students. Currently, where we have yes. Now let's move for the chemical reactions or chemical properties. We know, right? oxygen is present in alcohol. This oxygen acts as a electrophile, either electrophile or nucleophile. It depends. They react both as nucleophile, electrophile. I won't correct only because it's completely depending upon this R group. Whenever the same OH group is present in benzene, it acts as a electron donating group. Students, same OH group if it's present with methanol or any other compound. This methanol like a papam, it is very small guy. What happened? It is very small molecule just right now, students. Not this molecule. If it's a acyclic is nothing but if it's a long chain molecule, then this OH molecule acts as electron withdrawing. When benzene group donating, it donates the electron, then it acts as an electrophile. If it accepts the electron, then it acts as a nucleophile. Very simple. Right, my dear students? If it electron withdrawing, if it withdraw the electron, then it acts as a nucleophile and electrophile. Very simple. This lone pair is always attack the carbocation and forming a other alcohol molecule, and we know that either it forms ether. This is a preparation of ether. We can told this as also preparation of ether also. Then same thing. Also, if you have H plus proton, then this proton attack to this OH2 molecule, then what happened? Ethene molecule are deprotonation or dehydrolysis is happened. Then more the acidity of alcohols. Students, we already know whenever the alcohol, ethanol is reacted with sodium, it forms sodium alkoxide. Is nothing but ether compound is forming. Similarly, whenever we take tertiary butyl alcohol, it forms aluminium tertiary butoxide and other things. Sodium penoxide, everything is same. Here, students, acidity is completely depending upon this one. NaOH, ONA is forming, right, students? Here we have as in acidity of alcohol, we have this pattern. If it is a primary alcohol, then its acidity is high. The acidity character of alcohol is due to the polar nature of OH bond. Polar nature. It completely depends upon these R groups. If an electron releasing group CH3C2H5 increases, then electron density on oxygen tending to decreases the polarity of OH bond. If electron donating group is present, then its polarity it decreases. If electron withdrawing group is present, then it increases. Very simple. Here, if any CH3 group, any C2H5, any donating group is present, then its polarity, the electron density is high. Then it give entire electron to this carbon for the oxygen. Then electron density is then the electron density it becomes high. On this case, what happened? The polarity decreases, my dear students. The polarity decreases. Then this is a increasing order arrangement or decreasing order arrangement. This thing is happened. If 3 electron donating group is present, then its acidity of OH is low. If only one group is present, then its acidity is high. Then primary compound has higher acidity, tertiary compound has lower acidity. I repeat once, primary compound has higher acidity, tertiary compound has lower acidity. Very simple. Okay, students, I hope it's clear. For example, it acts as a base, acid, conjugate acid and conjugate base is forming. Very simple. Whenever we react alcohols, weaker acid than water, oh my god, here one important point is there. Alcohols are weaker acid than water. This can be illustrated by this reaction. Why alcohols are weaker acid than water? Definitely they ask the question. Give reason why alcohols are weaker acids than water. Because whenever we react the alcoholic base with acid, what happens? It forms conjugate acid and conjugate base. That's why alcohols are always weaker acids than water. Very simple, students. Okay, next more the acidity of phenol. We already know resonating structure of phenol. What happened? OH group. OH group, it acts as an electron donating. This bond is moved towards than this bond. This is a resonating structure. The reaction of phenol with aqueous sodium hydroxide indicates the phenols are stronger acids. Oh my god, what it indicates? Phenols are stronger acid than what? Alcohols and water. Definitely they ask in exam, students, why phenols are stronger acid than alcohol and water? Why, sir? Because Phenol, the reaction of phenol with sodium hydroxide, which indicates, it's only indicates, you need to write that reaction also. The formation of sodium ion, the sodium penoxide ion. You need to show that ion also. Okay, students. These are the few PKA values of some phenols and ethers. Look here, C6H4OHS. If it's nitro group, nitro group, it is an electron donating group only. It is an electron donating group. Whenever the nitro group is present at ortho position, it's next to the OH group. What happened? Its corresponding PKA value is 7.2. It is present at meta. Then the electron withdrawing nature is little bit low compared to, if for example students me and other Madhvi playing a game. What is that? Me and Madhvi is sit next to the any enemy or anything. What happened? If I teach you guys, for example, okay, I give entire clarification, I give different example. Imagine one classroom, the teacher is teaching. I am only teacher, I am only teaching the entire concept. Okay, what happened? The first bench students is there now. He listen my voice in higher compared to last bench students, right, my dear students? The last bench students, my voice is, whatever I deliver the voice, whatever I delivering the voice compared to first bench, last bench delivery is little bit low, right, my dear students? It is little bit low compared to same thing here also. If the electron withdrawing group present at next side or next position of phenol group, then its pKa values little bit lower than other values. If nitro group is present at para position, its pKa value is 7.1. For alcohol, it's 10. pKa is nothing but basicity value, right? That's why if electron withdrawing group is present in phenol compound, then it has higher pKa value, or lower pKa value. Definitely they ask the increasing order, either decreasing order. Then they ask either increasing or decreasing order in your JEE or NEET exam. Okay, my dear students. Then move on to the next chemical reaction, esterification reaction. We already know what happened whenever alcohols and phenols react with carboxylic acid and acid chlorides and acid anhydrides to form esters, either carboxylic acid, acid chlorides and acid anhydrides. We already know C2H5OH molecule, CH3COOH molecule, then which yield ester, sodium ethonate, right? What is sodium ethonate, sir? What it yields? C2H5COOCH3. This is a compound, ester compound, which yield ester with water molecule. This is called esterification reaction. Next, move on the reaction involving cleavage of carbon, CO bond. Yes, students, this is very important. This topic for entire alcohol concepts, phenol compounds and entire ether compounds. Okay, students. Now, already 1 hour is done. 1 hour class is done. Now, come on, let's take 5 minutes tea break. Now, it's a 5-minute tea break. Students, don't go anywhere. I am back. The session is exactly started. Now, what is the time? It's 1 o'clock, right? The session is exactly starts at 1:10. The session is exactly starts at 1:10 p.m. The session continue at 1:10 p.m. Please stay within the live. Go, just leave that mobile, just leave the live. Then go to the kitchen and had some tea or had some water and had some lunch. Don't worry, I give lunch break at exactly 1:45. Okay, either if within 1:45 I clear entire syllabus, students. Don't worry. In within 2 o'clock I clear entire syllabus. We have only few topics remaining. We have few topics only. Don't worry about it. Okay, students. Okay. Yes, students. Now we discuss entire chemical reactions. It's nothing but esterification reaction and further reaction. What happened? Protonation. If protonation is happened, what happened? We discuss now. Still we discuss up to that much. Then now we discuss what is the next reaction. Yes, the next reaction is reacted or the cleavage of CO bond. Whenever the alcohol compound which is reacted with any alkyl halide, what happened? The HX bond is broken and this H bond form a bond with this OH bond and water molecule is released with RX. RX is nothing but not a bike. RX not a RX bike. RX is nothing but alkyl halide, which means alkyl halide, not a RX bike. Everyone like boys, everyone like RX bike, right, my dear students? I also like RX. Whenever this type of reactions are come, I remember the RX bike. Whenever the RX bike is coming, oh my god. Oh, whenever the alcohol is reacted with alkyl halide, then it forms aryl halide. This thing you can easily correlate it or you can easily relate that things. Okay, my dear students, after that reaction with phosphorus trihalate, whenever the alcohols are converted into alkyl bromides by reaction with phosphorus tribromide. In unit 6 is already there. And also next reaction is dehydration. So dehydration, what Suhas sir, what you told them, dehydration, my dear students. We are already familiar with this reaction. Whenever the alcohol is heated in the presence of concentrated H2SO4 at exactly 443 Kelvin, what happened? The water molecule, the elimination of water molecule is happened. Then the alcohol compound converted into ethene molecule. We are already familiar with this reaction. Next one, the mechanism of protonation of alcohol. In first step, what happens, students? Alcohol which attack the lone pair present in alcohol, it attacked to proton molecule, then oxygen carries positive charge. This is a very fast reaction. First step, formation of protonated alcohol. In second step, similarly this bond, what happened? His second step is a slowest step. It's nothing but this one is rate determining step. Okay, rate determining step. Yes, it is also there. What happened? Here it is positive charge, right? Oxygen carries positive charge. What it do? It told to carbon, hey, give that entire bond. Then I am easily eliminated. Then the oxygen take entire bond of carbon, entire this covalent bond. Then it releases as water molecule. Further elimination of proton is happened. Then formation of ethene by elimination of proton. What happened? Here positive charge is there now. This hydrogen bond movement is happened. Then ethene molecule is happened. This is an example or this is a dehydration reaction mechanism. First step, protonated alcohol forming by the oxygen which abstract the hydrogen H plus atom or H plus ion. Then what happened? Protonated alcohol is forming. Then in second step, elimination of water happened. And this is a rate determining step. In last step, what happened? The movement of hydrogen bond is happened. Okay, my dear student, I hope it's clear. Then after this, oxidation, very simple. What happened? Whenever the ethanol undergo oxidation by using any oxidizing agents, what happened? It formed either aldehyde or carboxylic acid. For example, whenever you chromic oxide, it's forming, which is forming, aldehyde is forming. Similarly, PCC, aldehyde, and also whenever we have two different or secondary alcohols undergo oxidation in the presence of oxidizing agent, which is ketone compound. Okay, my dear students, this is about oxidation reaction. Then let's move for the electrophilic aromatic substitution reaction. Electrophile, what is the meaning of electrophile, students? Electrophile, E plus molecule. It is nothing but in this molecule what happened? This is deficiency in electron. Whenever it saw negative charge or whenever it saw the carbon have high negative charge, high electron density, this electrophile attack that thing. For example, here we know what happened. The oxygen, the lone pair present in oxygen is participate in resonance. It is participate in resonance. What happened? This bond is moved towards this. Similarly, what happened, which is undergo reaction, nitration is nothing but here H2SO4 is missing. whenever it undergo reaction in the presence of dilute HNO3 and dilute H2SO4, here we form two nitrophenols. One is orthonitrophenol, para-nitrophenols, and also we can easily separate these two phenols, ortho and nitro isomers, ortho, so not in nitro, ortho and para isomers, by using steam distillation. By using steam distillation, how it happened? By using their respective boiling point compared to para-nitrophenol, orthonitrophenol, which undergo intramolecular hydrogen bonding like this. That's why orthonitrophenol has high boiling point compared to para-nitrophenol. By using steam distillation, we can easily separate these two compounds, my dear students. I hope it's clear. Very simple. What happened whenever it undergo nitration? It forms both two products. It forms both ortho-substituted compound and para-substituted. It's nothing but whenever the electrophilic attack is happened, the electrophile is attacked either on ortho position or para position. Okay, at ortho position, para position, which is attacked at either ortho or either para. I hope it's clear, my dear students. Then after that, halogenation. Similar. Halogen, Br also, Br plus. It is also acts as an electrophile. Whenever it happens, it either attack at ortho position or para position, which is attacked at either ortho or para. But para bromophenol is major on this in this type of reaction. Ortho. Sir, no one is watching. Why you are wasting your face? It's okay, Rudraksh. After the live session, so many students watch it. After the live session, they watching. I know. If you only watching us, if any one student is there, it is enough for me, Rudraksh. Don't worry. It's okay, Rudraksh. Thank you so much for that. Students, look here. Students, what happened in halogenation? Whenever the halogen attack has happened in phenol compound, it is nothing but bromine in CS2 molecule or CHCl3. Or in chloroform or CS2 molecule, what happened at low temperature is nothing but at room temperature, 283 Kelvin. Below room temperature, what happened? Bromine molecule acts as an electrophile, right? Acts as an electrophile, which is attacked either on ortho position or para position. Para bromo compound is always major in the usual halogenation of benzene takes place in the presence of Lewis acid such as FeBr3, which polarizes the halogen molecule. In case of phenol, the polarization of bromine molecule takes place even in the absence of Lewis acid. Students, generally what happened? In the halogenation process, we use Lewis acid for benzene. But whenever the phenol compound is there, without Lewis acid also, it can easily polarize. It can easily attack. Okay. When what happened when phenol is treated with bromine water, it forms 2,4,6 dibromophenol. Instead of this, if we treated with bromine water, what happened? It forms tribromo compound. It formed tribromophenol compound. 2,4,6 tribromophenol compound. Right, my dear students? I hope it's clear. I repeat once again. Whenever it present with chloroform, bromine is present with chloroform, it is either para, either ortho. But para, it is a major compound. We need to mention para only. Whenever they give like this phenol compound, and after that they give bromine in CS2 or in chloroform at exactly 273 Kelvin, it is nothing but lower temperature. When they give A, B, C or anything, fill the reaction or complete the reaction. Whenever they give like this and they give 4 options: para, ortho position, meta position or nitrobenzene. Here the correct option is option A, para. Para bromophenol is a major compound in halogenation of phenol. Okay, my dear students. In the same case, whenever phenol is react with bromine water or react in the presence of bromine water with a tribromophenol, which is a tribromophenol, then move on to the important type of reaction, Kolbe reaction. Definitely they ask, what is Kolbe reaction? First, the phenol is fused with NaOH to form, which is what it forms, which forms ONA molecule. ONA molecule is nothing but sodium penoxide ion. Further sodium penoxide ion, which is reacted in the presence of carbon dioxide and further undergo protonation to yield 2-hydroxybenzoic acid. Very important, students, very important reaction. What is Kolb reaction? The preparation of 2-hydroxybenzoic acid from phenol. This reaction is called Kolb reaction. First step, the fusing is happened. The phenol is fused with NaOH compound. Then this compound, what it yields? Then it yields sodium phenoxide ion. Same compound. We are already familiar with this first step. After that, the sodium phenoxide undergo reaction, undergo electrophilic substitution with carbon dioxide. Next step, what happened? Electrophilic substitution reaction. CO2 acts and electrify. After that, what happens? COON molecule, COO minus and ONA molecule is forming. After that, protonation. After the same compound undergo protonation and it forms ortho-hydroxybenzoic acid. Ortho is nothing but next to the functional group, next position, either on this position, either on this position. Both are same, both are ortho position only. Right, my dear students? This reaction is called Kolb reaction. I explain one. Phenol fused with NaOH or alkali or sodium hydroxide, which forms sodium phenoxide ion. Further, it undergo electrophilic substitution reaction with carbon dioxide molecule, then which yield ortho-hydroxybenzoic acid. And also here another step is there, H plus protonation is also happened. Okay, my dear students. Next, move on to the Reimer-Tiemann reaction. Reimer-Tiemann reaction, and after that reaction of phenol with zinc dust, and after that oxidation, last one oxidation, benzoquinone process. These are all very important. They give this product, they give this reactant molecule or this substituent molecule. Not in substituent, reactants, right? Yes, the reactant and the reactant condition. They give reactant condition and they give predict the product. They ask predict the product type questions here, students. Reimer-Tiemann reaction is nothing but phenol which is treated on treating phenol with chloroform in the presence of sodium hydroxide. Chloroform, phenol which undergo reaction with chloroform in the presence of aqueous NaOH is nothing but sodium hydroxide, which forms intermediate compound. Further, this intermediate compound treating with NaOH compound to form which compound? Aldehyde compound, to form aldehyde group, and after that which yield aldehyde. The preparation of phenol by the preparation of aldehyde, salicylic aldehyde by using phenol is called Reimer-Tiemann reaction. In first step, what happened? Phenol undergo reaction in the presence of chloroform and aqueous NaOH. Phenol react with chloroform in the presence of aqueous NaOH to its intermediate compound. Further, which undergo reaction in the presence of NaOH molecule. Then after that, what happened? Which yield aldehyde. Right? Introduce at ortho position of benzene. A aldehyde group is attached at ortho position. Then this reaction is called Reimer-Tiemann reaction. There is no mechanism here, students. In your textbook, there is no mechanism, only reaction is there. Next, more on the reaction of phenol with zinc dust. Very simple. What happened? Whenever phenol is reacted with zinc dust, it's converted to benzene. This zinc react with oxygen molecules, then it forms zinc oxide. Then oxidation. Whenever always benzene is coming in my mind, students, phenol. Whenever the phenol undergo oxidation in the presence of any oxidizing agents or chromic acid, produce a conjugated diketone. It produces a conjugated diketone. Its name. What is the name of this compound? Benzoquinone. Whenever the phenol undergo oxidation in the presence of chromic oxide or sodium chromic oxide, right? Yes, Na2Cl2O7 and H2SO4 or oxidizing agent which yield benzoquinone or conjugated diketone. Next, move on to some important commercial alcohol. Some commercial important alcohol is nothing but ethanol. We already know, right? Ethanol, it is a ingredient present in drinks. Very important. How this ethanol is forming, students? The preparation of methanol. Methanol is nothing but what is the molecular formula of methanol, my dear students? CH3OH. CH3OH is a molecular formula. It's a molecular formula of ethanol. In the case of methanol, C2H5OH. These two are same. These two consist same functional group but these two have different physical property. Right, my dear students? Homologous in class 10 we already discussed. What happened? How ethanol is prepared? Whenever the carbon monoxide which undergo reduction in the presence of zinc oxide, chromic oxide, in the presence of ZnOCl2O3 at higher temperature and higher pressure, at 200 to 300 atmospheric pressure and 573 to 673 Kelvin, then which obtain methanol. Then we can easily obtain methanol. And in the case of ethanol, what happened? Very simple. Whenever the glucose is converted, intercase to a glucose and fructose, after that, by using zymase of fructose or glucose, then ethanol is forming by using glucose. Okay, I hope it's clear. Any doubt, my dear students? Then after that, by dehydration of alcohol, now ethers are coming. Now the entire ethanol and phenol done. Now ethers topic and synthesis of was this one as ether, then physical property, chemical reaction. After that, electrophilic substitution, nucleophilic substitution is there now? No, nucleophilic it's not happened here, only electrophile. Then after that, done. Students, we are at almost end of the class. We are at almost end of the class. Before entering to the next topic, I give simple clarification here. I give summarize entire topic what we done up to this. Students, mainly we learn alcohol and phenols here. What are alcohol? The compounds containing OH functional group. These compounds are called as an alcohol. And what are phenol? The compound containing OH group with benzene. The compound containing OH group, this OH group which is attached to benzene group, these are called phenol. We have different type of alcohol is there. Alcohol are classified on basis of two categories or three categories. If it's attached to double bond, it is called allylic alcohol. Very simple. Sorry, vinylic alcohol. Double bond is nothing but vinyl compound. Vinylic alcohol is done. Entire is done. Then after that, look here, students. Everyone concentrate here. And after that, what we discuss the preparation from ethene. How we prepared from ethene, high pranate. Very simple. How we prepare? Very simple. Ethene compound undergo what it undergo? Protonation, or it which undergo hydrolysis, which forms carbocation. After that, carbocation is forming, deprotonation has happened. Then we obtain alcohol compound phenol. From chlorobenzene, sodium peroxide ion is forming. Penoxide ion, everything we discuss, reactions. And after that, reaction of ethanol and phenol Kolb reaction we discussed, that Kolber synthesis we discussed, Kolb reaction, and other some synthesis discussed, zinc reaction, the reaction with zinc dust we discussed, entire we discuss. Up to this we discuss entire reaction of phenol and alcohols, entire it done, entire unit is done. Then remember thing is ether concept. Okay, students, remember the last topic is ether. In this ether we have preparation, Williamson synthesis is there, chemical reaction, physical property. After that, the entire syllabus is done. Alcohol, phenol, ether syllabus is done. Students, come on, let's take some break. Let's take from 10 minutes break now. The class is continue at 1:40 p.m. The class is continue. The session is continued at 1:40 p.m. Up to till. Stay with me, students. Up to that, stay with me. Go and have some water and come back and watch the session. Last part. We are at last part. Ether part. Preparation of ether, chemical reaction of ether, and properties of ether. Then last what we have few questions related to the alcohol, phenol, ether, the predictive product questions. After that, we can end the session. Okay, my dear students, thank you so much. Come on, let's take 10 minutes break. Exactly 1:42. I continue the session. Exactly at 1:40. Hello friends. Let's now come on Sunday with the last part of the session. We are at last part of session, right, students? First, the preparation of ethers. We already know by using dehydration of alcohols. If you dehydrate or if you're using dehydrating agent, we already know concentrated H2SO4 is a best dehydrating agent. If you eat a compound in the presence of concentrated H2SO4 at 443 Kelvin, then it is ethene molecule. If you decrease the temperature at exactly 413 Kelvin, we get ether, symmetrical ether. Okay, my dear students. And also same thing by using what happened here, the formation of ether is a nucleophilic bimolecular reaction. Is it nothing but SN2 reaction? What happened first step? Express protonation is happened. Then after that, protonation is attacked to another molecule. Here another molecule, same molecule alcohol is attacked to protonated one, the protonated alcohol. What happened? Then we obtain the ether, deprotonation. Then something is happened. Very simple. Then second one, Williamson synthesis by using Grignard reagent or alkyl halide or aryl halide. It is an important laboratory method for the preparation of symmetrical and unsymmetrical ether, students. If you take symmetrical compound, then you get symmetrical ether. Same compound, symmetrical method. Very simple. And alkyl halide is allowed to react with sodium alkoxide. Then you get the product. Very simple. Whenever the phenol compound which fuses with NaOH, then you obtain alkyl halides or alkoxide compound. Then react this one, then you obtain ether, symmetrical and unsymmetrical. This is also SN2 attack. Physical property: the CO bonds in the ethers are polar, and thus ethers have a net dipole moment. What is this meaning? So the first line, polar. These are polar. Okay, polar is nothing but this can easily form a bond. That's why compared to alcohol and ethane, these are exactly at middle. That's why affect their boiling point. The weak polarity of ethers do not appreciably affect their boiling points, which are comparable to those of the alkanes of comparable molecular mass, which is always comparable with alkanes. Corresponding alkanes, same molecular formula, alkanes. Very simple, students. The large difference in boiling points of alcohols and ethers is due to the presence of hydrogen bonding in alcohols. We already know intermolecular, intramolecular. The miscibility of ethers with water resembles those of alcohols, the same molecular mass. If we mix the ether and water, what we get? Same alcohol we get. What we get, my dear students? Alcohol we get. After that, chemical property, whenever which reacted with alkyl halide, same thing, alcohol is happened, and aryl halide or alkyl halide is forming, then same thing. Same thing is happened. Same what happened in alcohol place, no? It is also happened, same thing. Then electrophilic substitution reaction here. What happened? We already know oxygen is presence is nothing but they act as an electron donating group. This is an resonance structure, right, my dear students? What happened? If we do halogenation, it attack either on para position, ortho position. Similar to phenol, similar as phenols. Okay, similar as a phenol. Ether also gives same para and ortho substituted group. Here, para substituted group is a major compound. Okay, my dear students. Then after that, Friedel-Crafts alkylation reaction. Here, anisole which is reacted with alkyl and aryl groups are introduced at ortho and para position. If it's reacted with methyl chloride in the presence of anhydrous AlCl3, what happened? Either it attacked at ortho position or para position. Para position, 4-methoxytoluene is major compound here. Okay, my dear students, same thing is happened. Look here, Friedel-Crafts is done. Then what the electrophilic substitution? It's already done, right? Yes, this one. Then here, the product question is a HBr compound same. Look here, where is that HBr? Yes, if it react with HBr, then here alcohol, phenol is forming. Phenol is major compound and C2H5 bromo. Sorry, what's that compound name? 1-bromoethane. Okay. In this case, what happened? In the OHBr, it is same thing. CH3Br molecule and alcohol compound is forming. Alcohol is forming. Okay. For this one, nitro group substitution. It is nothing but electrophilic addition, which is attacked at either para position. Yes, para position is a major compound. Then for this case, HI, CH3 tri C OH plus C2H5I, ido compound. Very simple. This about entire alcohol phenol ether. Students, any doubt is there? You guys have time up. You guys have another extra 2 minutes now. If you have any doubt, then let us know in comment section. Everybody fast. Let us know in chat section. Everybody fast, fast, fast. My dear students, fast please. Students, fast. Any doubt is there now? Still you guys have any doubt, then let us know in comment section, my dear students. In this class, we discuss entire properties of alcohol phenol ether with IUPAC name, with chemical reaction, some naming reaction, Kolb reaction, Friedel-Crafts alkylation. Friedel-Crafts alkylation is nothing but we add the alkyl group. Alkyl is nothing but methyl, ethyl, any group to the benzene ring or to the ether compound. Very simple, by using CH3Cl and chloroether or chloroalkane or halide alkanes, alkyl halides in the presence of AlCl3, anhydrous aluminum chloride and CS2. Okay students, any doubt is there now? Students, still you have any doubt, then let us know in chat section or comment section. Fast everybody. Your Suhas sir is waiting now. Fast. Guys, any doubts? My dear bacho, any doubt is there? I hope no doubt is there. Then this is about today's entire class, my dear students. If you have any doubt, then let us know in comment section. Okay students, bye. Bye students. Stay tuned with your Suhas sir, and your Suhas sir always end the live session with beautiful smile. Bye students, take care, love you all, bye. Okay, then I take class at Monday. I take class on Monday, next class.